Boson Energy, we'll be listening to Heike Karl Zatterstrom, who's the CEO. Oh, sorry, CCO. My apologies.
Okay, I go ahead and share my screen here then. So my name is Heike Zatterstrom. I am here from Boson Energy, and I'm here to talk about waste to hydrogen to X. Okay, so as previous speakers have talked about, we are facing a number of challenges globally, including the 2 billion tons of non-recycled waste that is being landfilled and burnt. We are also facing major CO2 challenges, but the waste here actually represents an opportunity as well, because with a technology like Boson's, we can eliminate the 2 billion tons of non-recyclable waste and recycle it into hydrogen for local direct use or speed charging. And if we do that, we would actually reduce global energy CO2 emissions by 20%. And we can do that at radically lower system cost and 90% reduction of other emissions that are important, NOx, particulates, etc. And to do this, we have to reimagine waste. And Boson reimagines waste in 2 steps. First, we use waste to produce hydrogen in a thermochemical recycling process based on gasification. It's a distributed solution with modular execution, so minimal transportation and maximum distributed efficiency. And we can do that with 10 times higher profitability per ton of waste than incineration is capable to do. The second step is the hydrogen to X. Taking that hydrogen, which is a local fuel, which means that it requires minimal infrastructure and basically solves the chicken or the egg situation of the whole hydrogen economy. Because that hydrogen can be either supplied direct as hydrogen, but also as grid-independent speed charging from hydrogen. And this is profitable today at diesel or grid parity. So we're not waiting for this to be profitable in decades to come. And as I mentioned, both these steps are massively CO2 negative because we are diverting waste from landfill or incineration, and we are replacing fossil fuels in transportation. And there's also no grid stress, since both these steps can be operated autonomously without grid access. So what can this do in a hydrogen corridor or a city? There are a number of hydrogen corridors throughout Europe, also in Eastern Europe. They are signified by high economic activity, which means that there's a lot of waste produced, and that makes them ideal for hydrogen production and speed charging. Looking at the String mega region here, there's 6 million tons of waste going to incineration every year. That could be 600,000 tons of hydrogen instead, going to charging stations and used as hydrogen. And in Gothenburg alone, there is 55,000 tons of hydrogen potential. Boson has a strong Polish connection. We have been in hydrogen for the last 30 years through the research of our co-founder, Professor Blasiak, looking at how to extract hydrogen from solid waste and biomass through gasification. He worked together with Jan Grimbrandt, our founder, who is an experienced entrepreneur and clean tech entrepreneur who has spent the last 20 years also working in Poland, among other things, cleaning up coal power plant, flue gases, etc., in an earlier startup. He has sold 2 startups, one to Siemens AG and one to Nalco. And we have a lot of solid waste experience in the team. We currently have 10 projects in various stages of development, mostly in Europe, including Poland. We are looking at about 1 year until the first hydrogen is produced in a commercial demo plant. We have 2 projects submitted as national contributions, and through the first qualification step in the IPCEI on hydrogen. We also have 10 projects included in the European Commission's pipeline that is meant to fulfill the EU targets for hydrogen production by 2030. Our technology and execution partners include Siemens Energy, RHI Magnesita, Pyrogenesis, Immobit, and a number of other ones. So they are basically responsible for instantly scaling a manufacturing and assembly capability. And are we alone in the space? No, we're not. There is a handful of advanced thermal treatment players in the market. Boson has chosen a plasma-assisted gasification process, which means no ash, maximum flexibility on the waste intake, and minimal emissions. It's basically a keep things simple solution that is robust, efficient, and modular. And when it comes to competition, I mean, to tackle the 2 billion tons of waste, we will need to build 60,000 plants globally. And this is not undoable because these technologies represent an opportunity to leapfrog waste incineration and go straight from the landfilling that is still very used in Eastern Europe and a lot of also in the developing world. So here there is an opportunity, just like skipping from no telephony to mobile telephony, we here skip directly from poor waste treatment to the most advanced treatment without stopping at the burning, at the incineration. And to conclude, hydrogen from waste is not hopium. It is profitable today on market terms once it is being produced. It is actually a necessary shift from incineration, which is burning of waste, towards a thermochemical recycling process and a move towards the electrification that is necessary. One key difference here is that we can capture CO2 inside our chemical process, whereas incineration has to capture CO2 from flue gases, which is a lot more complicated. And for producing hydrogen, incineration is completely useless because it actually burns the hydrogen right away in the process and then uses the electricity to produce hydrogen from electrolysis. So as a result, you can only get 8 to 10% of the total hydrogen potential out of waste using incineration, whereas we can get up to 65%. So this radically cuts CO2 emissions, pollution, and power grid stress anywhere, also in developing countries, and also in countries around the Eastern European region. Our target is 1 million tons of circular hydrogen from waste by 2030. You're welcome to join us.